All right, I'm Brandon Clayton, the Algebra Guy, and today I want to talk to you about identifying prime and composite numbers. What is a prime and composite numbers? So by the end of this class or this lesson, you should be able to answer the following question: Is 91 prime or composite? So we'll go through some practice so you can answer that. So here's the questions in particular that I'm hoping to answer during our time today. Let me pull my questions up. All right, what is a prime number? What is a composite number? Pretty simple, right? So what is a prime number? What is a composite number? And I'm going to ask you questions to see if you can. I'm going to give you some numbers to see if you can identify which is which. Some numbers like 72 have multiple factors. For instance, you got 1 times 72 is 72. 36 times 2 is 72. 8 and 9. So 8 and 9. And we can go on and get all the factors because we've talked about that before. But there's some numbers that only have two factors, themselves and 1, like 7. So you can only think of two factors, two numbers to multiply, counting numbers, if you will, that would give you a product of 7. And because of that, we're going to call 7 a prime number and 72 a composite number. So just from that example, you probably get the idea, but let's go through and work out some more examples to make sure we have that down. So what is a prime number? So by definition, a prime number is a counting number greater than 1. So it can't be 1. You can't say 1 is a prime number because 1 times 1. So it's got to be greater than 1, whose only factors are 1 in itself, like we saw with 7. So 7 times 1 are the only factors, so that's a prime. What is or you could think of as a number with only two factors. What is a composite number? A composite number is a number, a counting number. A composite number is a counting number that is not prime, as we just talked about. In other words, a number with more than two factors, like we saw with 72. So here's some examples if you're needing some more to really draw this point home. So if I gave you the number 2, 2 has only two factors, 1 and 2, so we're going to call that prime. 3 only has two factors, but notice that 4 has 3 factors. So anything more than 2 will qualify it as a composite, because 4 times 1 gives us 4 and 2 times 2 gives us 4. So all these can be multiplied. 5 is prime, 6 is composite, and you can kind of see how this is working out. But anything that has only 2, we're going to call that prime. More than 2, composite. So you should get the idea from just those two examples, or just those examples. Is the number 83 prime or composite? So let's check. Did you get what I just said? Did that make sense? Is 83 prime or composite? So how do we figure this out to know if it's prime or composite? One of the things you can do, if you looked at our breakdown from the last screen, let me go back here. To figure this out, you could divide by the by the lowest prime number. So let me move on here. So if I have 83, and I just started thinking about all my prime numbers. So we could think about, start with the lowest. 1 is not a prime number, but start with 2. We can ask ourselves, can I divide 83 by 2? And we're going to say no. How do we know? Because it doesn't end with an even number, 2, 4, 6, 8, or 0. Can I divide it by 3? Well, 8 plus 3 is 11. That's not a multiple of 3, so no. That's not going to work. What about, I can't use 4 because 4 is not prime, but I can use 5. Can I divide 83 by 5? Well, 83, and to be the multiple of 5, it has to end with a 5 or a 0. It ends with a 3. So nope, not going to work. Can't use 6 because 6 is not prime, but 7 is prime. Can 83 divided by 7? I'm pretty sure it can't, but let's go ahead and do that right here. 7 gives me 13. 1 doesn't go into 13 equally, so it's going to be a decimal. No. 8 is a composite because it has more than two factors. 9 has more than two factors. So none of these are working. What about, let's see, 9, 10, 11. 11 is a prime number. Can I divide this by 11? No, because 11 usually has repeating digits for everything that's two digits, like 22, 33, 44, and so on. So 11 is not going to work. Let's see, 13. Can it divide by 13? No, pretty sure it's not going to divide by 13. In the end, you're going to see that this number, and you can pull up a calculator and just see if it gives you decimal for all these prime numbers. That is not a good line I was trying to draw. But we're going to find that this is a prime number because I can't divide it by any other of these prime numbers as I go down the list. And I could have kept going to 17. To see the next one be 17, 18, 19 divided by 19 to see if it works. And none of those are giving me the right answer. So we're going to have to keep going because we're not getting that whole number is what I should say. So let's erase that and try a different one. What about if I used, show you this screen here. I forgot I had this up here. So the last digit is not 2, 4, 6, 8. 5, it won't go into each. 7, it won't go into evenly. And 11, it won't divide. It gives you all these decimals, so no, these are not going to work out. What about 77? It's not an even number on the end, 0, 2, 4, 6, 8, so not with 2. It doesn't add up to a multiple of 3, so it's not going to be divisible by 3. Doesn't have a 0 or 5 to be divided by 5, but it can be divided by 7 because that gives me 11. 77 divided by 11 gives me 7. So that's more than one factor. So it is a composite number based on this test that we just did. So we take all these prime numbers starting with 2, go 2, 3, 5, 7, 11, 13, 19, and you keep dividing, you keep getting decimals. This is not a prime number. I'm sorry, if you keep getting decimal, it is a prime number. If you get whole numbers like we did here on the bottom, you get a 7, then you know that this does work out to be a composite. All right, and that concludes it. Did we accomplish our goal? We talked about what prime numbers are and what a composite number is. And the last question I did include is we talked about how to find out if it is prime or composite. We can simply just start dividing that number by the smallest prime numbers to see if we get a fraction, or I'm sorry, a decimal or a whole number. If you get a decimal every single time, it's a prime. A whole number is composite. Thanks for tuning in. Again, my name is Brandon Clayton, the Algebra Guy, and I'll see you next lesson.